Swayam Prabha. Digital India. Educated India.
And welcome back. So today's lecture, before we actually begin into the further modules, that is the actuator and sensor, I want to introduce you all to a very huge difference which is there in amateur robotics and industrial robotics. Most of the time when we start working, we start still thinking with our same old background that we have. That is, start with an Arduino, start with a small microcontrollers like MSP430, Raspberry Pi and those stuffs. And sometimes when we graduated, we also got introduced to some of the IO cards, that was maybe NI IO cards or PCI DAC or some other type of DAC systems which let us communicate with external devices using IO cards. Okay, so that is, we commonly call that as data acquisition systems. Okay, so using that we could very well communicate with industrial systems as well, but having that only in industry may be very, very difficult to go ahead with. Why? Because they are not industrially compliant sometimes. They are not standardized to be industrial product most of the time. I won't call it so, because quite a lot of NI DAC cards are also industrially safe. But yes, when it comes to compatibility with many other systems which are there in the industry, it becomes very difficult to expand your system to accommodate all various requirements which are there that you might face in the industry, to communicate with your robot, to say, like to communicate with IO cards, to communicate with other sensors, actuators, mostly the drivers and industrial PCs. It becomes very, very difficult. So let us just introduce you all to industrial kind of data acquisition system. Yes, it is a type of data acquisition system only, and it also has an industrial PC. Okay, so without talking much, let us move ahead. Okay, so yes, this is what you see is a type of industrial PC, which is PC which is from Beckhoff. It is known as C6030 series. So you see this PC has got this type of configuration. It is Pentium. Okay, so long back we have been working with Pentium in our desktops. Okay, but yes, why still that Pentium is still there in the industry? Because you know, industry don't go so fast. Yes, i7 processor with 4 cores are also available, but yes, they are extremely expensive. We don't need it actually. For most of the time, we want to do a real-time communication between our devices, input-output systems, drivers, and let us say if I am moving a robot in a trajectory, I should be getting feedback each and every moment in millisecond or sometimes microsecond rate, right? And having even a single millisecond delay sometimes kills our system, right? So we want to work with real-time system. We want to accommodate other input-output cards which are there. At the same time, we want to be very much economical, right? So that is probably one of the reasons that didn't let industry grow too much in terms of the processing power and those kind of stuff. But yes, we can manage very well with just one single processor. Can you imagine, even with Pentium 4400, G4400, 3.3 gigahertz, it is still gigahertz. Yeah, okay, so you got it. So it has so much of high frequency. If at all I can count on its clock frequency, I can convert this gigahertz frequency of processor to, let us say, 1 gigahertz communication from my sensor, I am done. I don't need it further, right? So I want to use 100% capability of my processing capability, right? So that is the reason I should be happy with 3.3 gigahertz if I can work with whole of the 3.3 gigahertz. So my OS is not capturing the processing capability. My GUI is not taking up that. Other applications which are running behind are not that computationally expensive that is scaling my processor capability. Okay, so got it. So that is the reason. Okay, so this also has got 4 ports, Ethernet ports. If you can see here, these are there. Okay, so these are Ethernet ports. So although it looks like Ethernet, but they are EtherCAT compatible. It can work with 1 gigahertz LAN. Okay, and it has very small amount of memory, and that is 2 into 4096, almost 8 GB RAM. Okay, DDR4 RAM, and SSD is its hard disk, you can call it. Yes, it is only 40 GB. 40 GB, but it is quite good enough. It only has to store the temporary data which is running behind. Sometimes the software which is running in the real-time system which is handled by, over here it is TwinCAT system. It can be VxWorks, it can be RTOS or something else. So only that is the application which is running behind, that is to handle the real-time stuff. Apart from that, your OS is there, and that is not killing too much of space. Okay, so yes, this is quite good enough. It is 24 volt power. You see it has some 24 volt input over here which can be fed from here, and it runs everything with that 24 volt. It has 4 USB ports. Yes, you can see it clearly, it is here. Okay, so that is USB ports. Ruggedized aluminum zinc die casting housing. They are very rugged to handle industrial environment, and it can dissipate power heat in very easily. Okay, so that is the reason it is made up of such material to absorb vibration as well as to transfer heat. Okay, so various mounting option is there. It can be mounted on standard DIN rail based system and many others. Okay, so various mounting option is there, and this can run TwinCAT real-time Ethernet. That is Beckhoff proprietary software to handle real-time communication between devices which are connected. And the background, it normally uses Windows IoT or Windows C over there. Okay, so yes, this can be integrated. What I have used for my demonstration also, that is multi-touch FHD full HD display, which is human machine interface that was added for visualizing the stuff. I can see what is going behind. Maybe I can have a SCADA somewhere in front of me so that I can do touch and operate my system, get some values, show it on the screen, so on and so forth. So that is the reason it is there. And it also has 120 watt 24 volt SMPS with an CU8130 battery backed UPS. UPS is there because for the same old reason why you want your system should not shut down immediately if at all there is any power failure. Got it? So that is the reason it is here also. So it is a 24 volt input UPS with 24 volt output also. Industry, all the supplies are normally 24 volt. So that is the reason I used to power up my system. So yes, industrial controllers, industrial PCs are like this. They look like this. They don't look like a traditional PC. But yes, this works. And sometimes they are DIN rail mount. Sometimes they also have DIN rail mounted PC with add-on cards. You can keep on adding cards to it. Those options are also there. So this is a type of industrial controller. We call it controller, although it is a PC, because it is the one which is handling all my IO system, and maybe it is having the kinematics of my code. Okay, kinematics part of the program. Maybe that is handling the closed loop operations which are there. So that is the reason it is known as controller. Yes, there is one very good stuff which is known as EtherCAT coupler. EtherCAT coupler. It is a type of coupler to do some sort of industrial communication. You see, it has an input Ethernet looks like Ethernet. It is Ethernet protocol, that is EtherCAT. We commonly call it as EtherCAT. It is again a Beckhoff proprietary. We will talk about different type of Ethernet based communication system after this. Okay, few slides after this. And there is an output EtherCAT also. So yes, it has two RJ45. This is RJ45 sockets. Okay, so with this you can extend these devices, and maybe you can have multiple number of such devices, we can further add on IO cards on top of it. Okay, so I'll show you that, don't worry. So yes, the number of extension, you can keep on adding cards on top of this is as much as 65535. This, if you remember, this is value of int. Okay, so that is 65535. So and further EtherCAT extension is possible. You can have IO modules which can be fitted after this one by one. Okay, that can go here, or maybe you can attach further another similar EK 1100 after this and maybe extend your devices further. Okay, so you can keep on adding that. Okay, so that is how. So yes, now you also have system field bus supply 24 volt 10 amp. So after this it has a field bus E-bus connector, so that transmits the continuity. Yes, let me just show you one of such cards which is there with me right now. Yes, maybe I can show you right now at the moment. Yes, so yes, so this is one such system that I have in my hand, which you can see. So this is your EtherCAT coupler. You see, this is a coupler which looks like this. Okay, so it has two Ethernet ports here. Okay, so this is the DIN rail which is normally mounted in the control panel inside, so that you can plug in all the cards after this. So you see how it goes. Okay, so this is your EtherCAT coupler. Okay, so this is your EtherCAT coupler which is there. Okay, so see how it was fitted to the DIN rail. It simply went in here and you can push it simple. Okay, you can simply push it. So you see there are contacts which are here. Those contacts establishes its contact with this. Okay, so once you connect this, you slide on top of this, it immediately gets connected to rest of the system which are there in the bus. Okay, it is not that easy to put in from this. Okay, yes, so now you see it has gone in. So there are methods to lock it also. If you see it clearly, there is a lock which can be locked like this to the DIN rail. Okay, if you unplug it, you can push it. So yes, now it has found its slot and now you can lock it. So same way I can pull out any of the cards which are there. So you see, I can simply pull out one of the card which is here. See, so these are different IO cards. So see, they are very modular in nature. So all these cards have got some specific function. They are known as IO cards. Sometimes they are motor drivers for digital input output, for analog input output, to running a motor, to interfacing, let's say, strain gauge force sensor or many other kinds of sensor. So this is just one card that I have just pulled out from in between. Okay, so yes, if you just push it back, it will go. Okay, so now it has plugged in. So all the devices which are here are one by one, they have a specific function. So hope you got the view of this. I will discuss further when we'll come to it. So it has, first thing that was there is, one of them is surge filter, EL9550. That is a surge filter system. So the power comes into this. From this it is going to the controller, so that any sort of over voltage, lighting, dynamic disturbance which are there in the supply can be simply eliminated. So that is the reason it is there, and may be attached with digital analog, digital input output cards which are there. Okay, so yes, so going to the next, this is one of the brush DC motor motion interface, that is EL7332. That's again a Beckhoff one. So it has a DC motor interface also. So if you, I don't know if you can read it clearly, they are EL7223. They are EL7223. That is the DC servo motor controller. I will be working with DC motor controller also. So this doesn't have that card in particular. Yes, each of them, they have a add-on module which increases its power rating, and then you have this type of small fan system which is there, that enhances its further current carrying capacity. Got it? So this is the way it is fitted. Okay, So it goes to its slot, so they need external connections again. Okay. Yes. So these are some of the IO cards. Yes. Industrial communication. Yes. This one follows EtherCAT. There are many other type of internet communication network, industrial communication protocols. Why is it important? Because in industry you need to be very much system should be very much reliable against any sort of undeclared commands if that goes in, any sort of interception if that happens, okay, from over the internet if it is connected. Okay, so that should be very safe, and you should be electrically safe also to take care of any sort of electrical noise for long distance communication and so on and so forth. So that is the reason. So there are many established protocols which are there. Some are based on serial protocols, some are Ethernet based protocols, some are proprietary development, some are general development for the world, which is now for the world it is open. Yes, so yes, this is Ethernet IP. ControlNet International Limited has developed this in 1990. That is common industrial protocol to standard Ethernet. Leading in US, this particular protocol is very much popular in industry in US, and also 30% of international market share is by Ethernet IP based system. Okay, so that is a communication network that you have seen. You had something which was there earlier, no? Over here you had Ethernet look like thing, no? So this can be EtherCAT, this can be various other type of things. Okay. Okay, so this is a controller control thing, and then it is managed by Open Device Vendors Association, Open Device Net Vendor Association, ODVA commonly known as. So now this protocol is open for the world, nothing is just proprietary. So it is used by various other makers also apart from ControlNet International. So any other company, they are making their devices, they can make their devices compatible with this also. Okay, so that is one. And then you have Profibus system, Process Field Bus system, promoted by BMRF, that is the German Department of Education and Research. It was established in 1989, later on used largely by Siemens. Siemens is a global manufacturer for different type of IO cards and PLC based systems. Okay, so everything that you see in industrial automation, most of the things are now made by Siemens also. Okay, so Profibus is one such protocol which is followed in the world. These are some of the symbols which are there. Okay, some of the commonly used logos of each one of them. So this is for EtherCAT, that is proprietary of Beckhoff. Now it is again open to the world. Other companies are also using it. Modbus is there, CAN Open, CC Link IE, EtherCAT IP, DeviceNet. So we'll talk about each one of them now. Okay, so next is DeviceNet, which was established by an American company called Allen Bradley. Now it is Rockwell Automation. Application layer over CAN bus, controller area network, that was established by Bosch. Okay, so initially it was there. Now it has this application layer, and now it also adapts CIP, that is Common Industrial Protocol for this. This again is managed by ODBA. These are few of the network protocols like Ethernet IP, DeviceNet. These are a few which are managed by open source thing, not open source, it is basically managed by Open DeviceNet Vendor Association. They are low cost, robust as compared to RS-485. 485 is very similar to RS-232, which we commonly use. We call it as serial port, UART or USART type of communication, which is commonly used with Arduino and those stuff. Okay, so it is just a level higher up based on RS-485. It is DeviceNet. Okay, and then you also have a very common, very widely used, and that is a protocol which is mostly used over industry, is Modbus protocol, developed by Modican in 1979. Most widely used one, versions are serial. It started with serial, now it is RTU, that is a 3-wire communication kind of thing, and TCP IP is again a type of Ethernet based system. UDP, the UDP is also there. Okay, and then UDP is very commonly used protocol in Ethernet. Okay, so Modbus plus communication is there. Yes, they have some limitation. Because it was developed somewhere in 1979, it was very much limited with bandwidth, that is the number of bits of its operation. So large binary objects are not supported. So yes, it can handle only 247 devices as compared to EtherCAT devices. It has some 65535 devices. Okay, so that is a 16-bit system. Maybe this is just 8-bit system for addressing maybe. Okay, so it has very less or no security at all. So one-to-one connected, unauthorized commands are acceptable and even it can be intercepted. But yes, it can carry long-range transmission and it is pretty safe and used widely in the industry, and most of the devices, they support this. Okay. So yes, there is one very good thing about this kind of protocol. One of the protocol is Open Platform Communication Unified Architecture, OPC. It is commonly known as OPC UA. It is a cross-platform development. It is not developed dependent on any type of OS on which it is working. Let's say it can work on Linux, it can work on Ubuntu, it can work on Windows IoT or Mac sometimes. Okay, so and it is open source also, and IEC 62541 standard for data exchange from sensors to cloud applications developed by OPC Foundation. So it is defined over there. Okay, so this is open source also. If somebody is looking to develop their own devices, and they can simply adapt this kind of open definitions which are existing. Okay, so and you can develop your device which is now acceptable to the industry. Okay, so and EtherCAT, definitely EtherCAT is one of the best because it targets real-time operation. It has a closed loop cycle frequency of something around 100 microsecond or less. So it is a Beckhoff proprietary, which is now commonly used by many other makers also. Ethernet for Control Automation Technology, that is CAT, Ethernet. So Ethernet based field bus system developed by Beckhoff Automation is standardized again in IEC 61158. Both hard and soft real time is possible. Hardwares are mostly real time. They have very low clock frequency. Okay, very high frequency of communication they can do, sorry. So that is what they can do, but yes, it has also capability to work on software with some real-time stuff also. So they have a layer on top of it that can implement this, which is TwinCAT, they commonly call it. So TwinCAT is a layer that reserves one of the processor to do some real kind of stuff. So even that can be installed on a standard PC and it can do real-time communication. Okay, so that is one beauty about it. Okay, so yes, so with this, yes, this is one of the introduction that I gave you for this. Okay, apart from this, not just this kind of stuff which is there, that is a EtherCAT based system that is done by Beckhoff with good industrial compliance. So all sorts of cards you can fit. Okay, so what all cards which are here, I'll quickly show you here. Maybe, yes. So if you can go here, I'll switch off this one. Yes, so this had this card that is EtherCAT terminal, one channel motion interface servo motor. So yes, it was here. So these were the servo motor interface. I wanted to interface almost 6 servo motors, so that are accommodated here one by one. Okay, another one in the queue is this one. Okay, so that is the fan cartridge that you saw that time. Okay, so this is the fan cartridge that adds on to the servo drives so that you can run it at higher current rating. Okay, and then you have another device that is EtherCAT terminal, that is a 16 channel digital output that is at the end, which was there. Okay, so that is there. So this is the one. So last one in the queue is this card, which can take in all sorts of digital output from here, 16 channel digital output from here. So all are connected one after the other, and you can extend this to 65535 cards. Can you imagine? And then you can put all those cards in series with some other EtherCAT coupler. So you can see how many devices you can integrate. Okay, then you have a end bus connector. So that is again very common. So at the end you see this is the one. So this is the one which is there, EL9011. That is the bus cover. Normally the terminal should not be left open. So at the end the terminal is covered using that. Okay, so this is just a cover, nothing else. Another one is this one. Okay, so that is EL6070, that is EtherCAT terminal. That is the license for, yes, this is the one. So one of the key is for license key for the TwinCAT. I told you it is a proprietary software. TwinCAT is a proprietary software that allows you doing real kind things. So it also comes with a license which is sold by Beckhoff and resellers. Okay, so yes. So yes, this is one, and the last one which I had here is this one. Okay, so that is 6080 EtherCAT terminal, one channel communication interface, that is for the memory. So I wanted my memory to be extended as well. So this is additional memory for the runtime operation also that is there. So you saw this is one of the very popular IO system which is there. So now I'll talk about a similar one. So all industrial systems are almost similar one. I'll show you yet another one that I have in hand now. So yes, I'll again switch on my camera here. Yes. So you see this is the power supply, which is also DIN rail mountable. This time the way it is connected is through this. I can pull it out and it comes out of the DIN rail. Okay. So again you have a similar one. This is a Modbus protocol. So these two Ethernet ports are for Modbus. I'll show you the actual thing now. Yes. So this is a Modbus TCP network adapter. So this is here. Quickly can look at. So this also can be taken out like this. So this time the way it was connected to the DIN rail is something different. So it holds these two pins. They hold the DIN rail and it can be taken out. See, now it holds and now it is released. Holds, release. So that is the way, and it can be plugged in very easily again back to the system. Okay. So this is how it is fitted. And then you have same way, you have multiple numbers of IO cards which are fitted one of the other. So there are many similar systems. Again, I'll show you one by one what all cards which are fitted here. Okay. Yes. So this is one of them, and then I have a card which is called a 16-channel digital input card, CT121, that is a digital output card, and there is a 16-channel digital output, and then you have 8-channel voltage output. Again you have RTD, that is for temperature interface which is there. So you see input, output, digital input, digital output. So all sorts of things can be done from these type of arrangements, you see. So yes, all these can be mounted on your control system. So now this lets you communicate to your system. This lets you communicate to your PC. So now you can have all sorts of controller design. Okay, the way I have designed for many other stuff, I'll show you one. Okay, one. So now you can build your demonstration. So one such demonstration was this, where I have used a coupler. Okay, this is a filter. This is the filter which was there for the Beckhoff system. I'll show you now. So yes, that is the filter. So I must keep this one here. So yes. So this is the way it was. So one by one different cards are there. So this is your EK1100, that is the EtherCAT communication protocol interface, EtherCAT to communicate with different. This is the coupler for IO cards. So IO cards that goes one after the other. So this is the coupler, this is IO card, this is filter, and this is your motor driver. So you see you have a PC which is an industrial PC here, and you have HMI which is here, we have HMI here, and this is your DC motor. It can be anything, not just this motor, it can be even a servo motor, a stepper motor, maybe a sensor or any sort of stuff. This is the UPS. Okay, so from your external power source it goes to the UPS, from UPS it goes to the PC, industrial PC, and PC finally communicates through this channel to the IO cards. It is both input and output. Okay, so from the filter it is powered so that you don't see any noise that goes to the IO cards. So you see, this is how you get bidirectional, you can do bidirectional communication, you can create a closed loop system on your PC which works on real time. So that is how you can design hardware controllers. So this is the reason why industrial systems are so different, because they are very rugged. Yes. So this is how, when it comes to building a system, so I created actuator demo which will be covered in this course using this. So this is your UPS again, this is your UPS, sorry, this is your IPC, industrial PC, this is your UPS, and that is powered through external power supply which is lying somewhere else. That is a 220 volt to 24 volt supply that is powering this one. And then you have EtherCAT system which has EtherCAT couplers which connects all the IO cards, motor drivers. It is powered by surge filter to discard any sort of electrical noise, and all the motor drivers are fitted here one after the others. Okay, so this is how I am controlling all of them using my PC. So I can do it even without a industrial PC. I can do it even without an industrial PC. Mind it, this can go. So instead of using an industrial PC like this, I can simply remove this. I can put my own standard PC and still I can communicate using EtherCATs. In that case, you just need to have a maybe Profibus card fitted on your system in your PCI slot, or maybe you can just have a Ethernet card and you can implement at least Modbus and EtherCAT which easily through this, okay, through your standard Ethernet card. And then these IO cards, these Ethernet coupler, these manufacturers, they also provide APIs for their softwares. And Modbus, they are normally free. Over internet you will get plenty good amount of drivers which can communicate, but yes, you have to go thoroughly with the data sheet of Modbus communication before you actually make such controllers. So yes, that was not the motive behind explaining all these to you. This is to expose you to the kind of difference which exists in the industry. The way we are brought up while my undergraduate days, now when I go to industry I have to handle all this. So this is where this course will create difference, you know. Now you should not, you should stop rather using your old IO cards, and yes, you can definitely do academic stuff, but when it comes to industrial robotics and industrial IO system, industrial sensors, actuators and other systems in the queue, so you have to take care and you don't have to use your Arduino board. You see, your washing machine is not delivered with an Arduino board. Maybe industry is not using Raspberry Pi. I won't say that firmly over here, because maybe at times people, they do fit it, but it is not practically safe to do it. Okay, so that is the reason. So industry, they run on all these drivers, and you have to be very familiar with these stuffs so that you can create your own control system which are very safe, and they can be directly deployed to the industrial shop floor. Last but not the least one, and most importantly, you should start using this kind of wires, you know. Most of my projects and the products that I make, normally I use this kind of wire, and you also should start using it. This consists of each one of them, you see it has two ends. Each end is now fitted with kind of lugs which fit like a cap okay, and you have a crimping tool with which you can just press in and you can make customized length wires of quality wires, copper conducting wires, okay. So get use, I have seen mostly in hobby electronics, amateur robotics and competitions, normally students they use kind of jumper wires which are very unreliable. You see most of the project they fail because of that, okay. So they can connect unreliably, okay. So with this they have a dedicated even my motor driver, it has a dedicated sockets over there. You see if it is here, no, it has a dedicated socket which is here, okay. So these sockets, no, you can just press it in using a standard screwdriver kind of thing, and you just push it and it gets fitted very well. And even the terminal boxes, they have similar kind of thing. So they connect very reliably. So connections are very important. Wires are very important. So take care. You should use proper wires also for your projects. Okay, that's all. Okay, so that's all introduction for this. So after this, I'll be covering actuators that will be using similar setups. Same amount of DC motor I have shown you here. See, this only will be used for DC motor. I'll come back to this once again when I'll be covering DC motor. I'll be using stepper motor with this. I'll be running a servo motor with this. These type of system. I'll be interfacing all sorts of sensor in the sensor module also. Okay. So that's all for this lecture. So hope you are quite exposed to this kind of system. You are ready to take up this new challenge which has come to you now. You can replace all, even NI DACs are not that cheaper, okay, so they are expensive too. So yes, this also is very expensive, but they are IP certified, they are CE certified, they have huge amount of certifications which are there, and they are run by different class altogether. Okay, so yes, my best wishes to you all to come up with that level so that you can make things which are industrially acceptable. Okay, so do robotics with a better systems which are acceptable. That's all. Thanks a lot for this. Next lecture will be covering actuator, after that sensors that will use all this stuff. Thanks a lot.